They are non-viscous or almost non-viscous, almost non-turbulent, and almost non-sticky. And then, if you have got that situation, you can apply Bernoulli's equation. How do you do this? Well, you consider your tube. Here it is, with the constriction. You have a laminar flow through there. And you write down, that's the first step, you write down your Bernoulli equation. State the equation. You have to do that for 2 points in order to get an equation. So let's take the point into the tube and the point out of the tube. On the input side we have the pressure, the work performed onto the volume element, plus its kinetic energy, plus its potential energy. So we need to define a height. If we place our horizontal tube on the ground, then this would be our height scale, and we are at 0. Then on the other side we have pressure 2, kinetic energy 2, plus potential energy term 2. Now you see, this is an equation with 6 variables, and you know it cannot be solved for one of them unless you know 5 of the others. At the moment we don't know anything. So in order to solve the Bernoulli equation, which is just a single equation, one needs to constrain it using what we generally call boundary conditions, or what one could also call the situation of the problem, the circumstances. That's the second step of the solution. Consider the situation, because that will possibly, not always, but possibly rule out some of these terms. In this particular case, I've already said, we're flowing in a horizontal direction, so the height, h, is unchanged. In fact, we can define a zero reference, and if we define that zero reference exactly in the center of this tube, we find that both of these heights, h1 and h2, are 0, and therefore the respective terms become 0. That reduces our equation to an equation with 4 variables. Yeah, P1, V1, P2, V2. The density, of course, is also unknown unless you know what the fluid is, but that's often the case. So you need to know what the fluid is and look up the density. Now we've still got 4 variables, and we can only solve it if we know 3 more of those. But you might know the pressure on entry, or you could measure it with a manometer, and you might be able to measure the pressure on exit. So this might be known, and this might be known too. That means if we now put in a device which measures the speed on entry, V1, we can solve the Bernoulli equation for the speed V2. And that's how it's done. Look what's happened here. Our solids become a fluid. It clearly is non-Newtonian. This is the kind of fluid you cannot apply the Bernoulli equation.